Okay, let's review a little bit, guys, of the construction, because we'll be doing some construction today. If I have a segment, AB, I think this is one of the first. Let's just review. If you forgot, then you should write it down. But let's just review first. How do we bisect this so that you get a midpoint? But not only do I bisect, I want to draw perpendicular bisector. Right, guys? Remember how to do this? How about David? What do I do?
Are we making notes on this?
So you have to set up your compass.
Yeah.
You have to put one point on A, and then you have to put the other point more than halfway.
Yes.
And then
Very
you
good.
have to go up and draw an arc. And then
Yeah.
go to B and draw another and do that for the top and bottom.
Very good. So we basically, with the compass, we do this, and then do the same with the same radius. We do this, right? And then was that well? If I do this, I have to put one down here because then you need 2 points for line, right? And then I do the same with the radius. Do this, that, and then I draw, right? And then this is not only midpoint, but it makes 90 degrees. You guys remember that one? Okay. What if I have a line? You're gonna have a point A. What if I want to draw a perpendicular line through A? Then do you guys remember how to do this? It's similar to the one we just did here. Who remembers how to do this? Leo?
You do from point A, you draw 2 arcs.
Yeah, you draw 2 arcs with the same radius. Do this and this with the compass. Then what? And you do the same thing here, right?
Yeah.
Right, exactly. But do I need 2 points, top and bottom, or just one now? Just one because I have a point here, right? So I could with my compass, I just need to do one here with the same radius, and then put one here, and you do that, and then, of course, we know these two are congruent because that's how we constructed it, right? And then this is 90. You guys remember this?
Are we doing notes?
Who could explain to Jack what we're doing now?
We're reviewing Jack.
Yes, Jordan.
We're reviewing it, and then if we forget anything, then just put it down.
Oh, how did you know that?
Since you told us.
Oh, okay. Very good. All right. So, does that make sense? Now, so that's some of the construction that you need to know, right? Review a little bit, so forth. By the way, why does this work? Do you guys remember why these things work? Because that was the important part. Like for the first one, why does this work? Basically, what are you drawing here? Yes, Brandon?
You're drawing a rhombus.
You're drawing a rhombus. Is this, okay, look. If I were to connect this, right? Didn't we make it so that these are all congruent? And don't you have a rhombus? And what do you basically have? You have a diagonals of a rhombus, and you know what we do. You know what they do, right? They are perpendicular. You guys remember? Okay. What about this? What are we doing in this case? We're basically drawing a. What kind of triangle is this? Isosceles triangle, and guess what? This is the midpoint of your base. Isn't that what we're doing? So since these two, that's how we constructed these two sides with the same radius with the compass, right? Don't you have an isosceles triangle? You guys remember that? That's the thing that you gotta remember, right? You have to understand why this works, okay? What sort of idea is behind it? One other thing that I want to review, this is not construction, but something from chapter 9. And like I said, this is why we want to do all this construction. So if I have a circle, okay, let me make it a little bit better. If I have a circle, okay. And let's say that I have a semicircle. Okay, so here's my center. Oh. If I have a semicircle, right? Do you guys remember if I were to draw any triangle in here that's inside of a semicircle, what kind of angle? This is right angle, right? What if I do this? Let's do it. Do you guys remember why? Okay, who remembers why this is true? Jocelyn, do you remember why?
Because the measure of a semicircle is 180, and the measure of an arc inscribed in it is half of that, so it has to be 90.
Exactly.
Makes it right.
Yeah, right here. What's the measure of this arc that is intersecting? 180, so this angle must be 90, right? As long as the triangle fits inside a semicircle, right? If you have a triangle inside a semicircle, it's always going to give me 90 degrees. So those are some of the things that we need to remember when we do this construction today. Is that okay? So knowing this, let's do our first construction. Okay, here we go. Now this time, just follow along. I'll give you time to actually construct it yourself after we're done with this. Is that okay? Don't do the construction while we're doing it, because then people will ask me the same question and so forth. All right, so just get out your notes and just listen for now. And then after I tell you, then you could do it. Okay, so our construction again, please. Okay, stop playing with the compass. Okay, here, take a look at what we're doing. Put it down. I don't want to see any pencil, nothing. Just put everything down. There you go. Yeah, sure. You don't have to do that, but just don't do it. Okay, somebody read what we're going to do. How about, can you read this for us? How about Kylie?
Frozen.
Kaylee, I mean. Go ahead. Here we go. Thank you. Kaylee, can you read this for us? What are we doing?
Construct a tangent to the given circle at the point P on the circle.
Yeah, so that's what we're going to do. You see on a circle, we want to draw a tangent line on this. Can I just get a straight edge and then just draw a line on P? Is that good enough construction?
Yeah.
Not really, because how many points do you need to draw a line? Two. We only have one. Yeah. Well, but if you drew OP right here, that's not a tangent to this circle. Yeah, we want to draw a tangent on P. Right? So we need another point, right? Does that make sense? So let's see how we could get the other point and what to do. So we know, first of all, one other thing that I wanted to talk about is if I have a circle, do you guys remember this? If I have a circle and I have a point here and there's a tangent line, okay? What kind of angle does this point of tangency and the radius make? This is one of the things we learned. Yes, Reagan? It's a right angle. You guys remember this? So knowing this, we're going to construct, we're going to do this construction. Does that make sense? So that's the other piece that you had to remember. But a lot of you already knew that. So first, what we're going to do is we're going to connect OP. Okay? So of course, we do that with the straight edge, right? We connect OP. And what we're going to do is, because we knew that the radius and then the tangent line is going to be perpendicular, guess what? Yeah, we're gonna make a right angle through this point P, which is kind of like the one we just did right here. You see what I mean? It's the same construction that we did. It's sort of, yeah? So what are we going to do next? Well, we're going to first figure out, we're going to get these two. So actually I said the first one. It's the second one. We're basically constructing a, what? Yeah, using the isosceles triangle. Isn't that right? So we're doing this part right here. We have the two base of this, right? We have the base. Now they're equidistant from this P. The P is the midpoint, right? So we're going to now get the vertex by doing it this way, so as you expected. Go more than halfway and connect. You could do either side, doesn't matter. And do the same thing on R. And now how many points do we have? 2 points. Guess what we're going to do next? Connect them. And so you see how the radius and the tangent line, they're 90 perpendicular? Knowing that, we're basically drawing a isosceles triangle right there to help us to get the construction. Yes? Okay, does this make sense? All right, now it's time for you to try. Okay, go ahead, everybody try. Next construction is this construct. Who would like to read this? How about Hannah? Over here. Can you read this for us? Yeah.
Do I meet the goal?
Yeah.
Construct the tangents to a given circle to a
Okay, so you're going to draw a tangent. How many tangents can you draw from the point outside of the circle? Two. We're going to draw these two tangents. Is that okay? To do this, let's just do two for now. Okay. To do this, I want you to think about this thing we just talked about. You know that if we have a semicircle, right? What's the triangle that fits inside a semicircle? Sorry, what's the triangle that fits inside a semicircle? What's the angle? Right triangle, right? Okay. So keep that in mind as we do this one. So what we're going to do is, let's see if you can figure this out. This one does require you to kind of pay attention in terms of why this works. First, we're going to connect OP. Okay. That's easy. Okay. Just get a straight edge, connect, right? From the center of the circle to the point outside the circle. Is that okay? What we're going to do is we're going to find the midpoint of this OP. Okay, so to do this, to find the midpoint of OP, what do we do here, Josh? What do you think? Think about what we did here. We reviewed a little bit. How do we get a midpoint? Which one do you think we need to get a midpoint of a segment? Do you remember what we did before? Look at the very first construction we did. Do you remember that one? We had a segment AB and we were able to draw a perpendicular bisector, right? Well, that would give you a midpoint, wouldn't it? you remember that? So what are we going to do, Josh, here? Right? Right? Yeah. Top and also in the bottom, and then what do we do afterward? Go to P with the same radius, correct? Very good. So just like Josh said, we're going to get a radius greater than the midpoint of this OP and connect such a way, right? So that what do you have basically, guys? If I were to connect this, these are the diagonals of a rhombus, and then isn't that perpendicular? Okay. So the reason why we did this is because we're going to we're going to draw a circle using this radius we just found, the half of OP. Okay. And when we do, you see what we're doing here? We get the radius half of this, okay? And we're going to draw a circle. Well, not really a whole circle. We're just going to connect. We're going to connect the intersection. If I was to draw the whole circle, wouldn't it intersect this blue circle in 2 points? So we're going to do that. But it's easier if you think about it as a whole circle. It turns out those 2 points are the point of tangency of PJ is a tangent, and PK is also a tangent to this circle. Let me finish drawing. Why should these two be the tangent lines from the point outside the circle? Like I said, it's actually easier for to draw the whole circle around this. Okay. I want you to think as a group why this might be true. Okay, go ahead, everybody. Go ahead. Why should? Because it turns out these are the tangent. Why should they be tangent? Go ahead, everybody. Think about this. So let's take a look at this. I actually drew the circle around that. I try to fit it as well as I can. If I did this, who can explain to you why the PJ and PK are the tangent to this circle? How about at J and K? How about who could explain this? How about Brandon?
Oh, okay. So if you look at the bigger circle, OP has to be the diameter.
Yep.
So that means it cuts it into 2 semicircles.
That's correct. So what?
So then angle OJP would be an inscribed angle in a semicircle. So it's a right angle, which means that's the point of tangency with the smaller circle.
Very good. Narek, can you explain to us again what he said?
I don't get it.
Guess what he was doing when you weren't paying attention?
No, I was asking Leo if that was the same thing that he said, because I didn't get what he said either.
So let me ask you this question again. What do you think he was doing?
Explaining it?
Do you think it might have been a good idea to actually try to listen?
Yeah.
Okay. Let's help Narek understand what this says. Okay. Who could explain to us again? Brandon just explained it nicely. Who could help us understand what this is saying here? No one else. It wasn't just Narek. Oh, okay. How about Reagan?
Okay. OP is a semicircle, and then angle PJO has to be a right angle.
Good. So Narek, here's the key. You see this triangle that we just fixed, triangle in black, right? Let me do this in red. If I were to connect O, JO right here, what kind of triangle do you get?
Right triangle.
Why? You're right.
Because it's inscribed in a semicircle.
It's inscribed in a semicircle. And because this is a right angle, what do you know about the radius and the tangent? What kind of angle do they make? If this J is a point of tangency, and then isn't OJ a radius of this blue circle?
Yeah.
So guess what JP has to be? Let's go back to our first. Let's look at some of these things that we just talked about. Do you remember if I have a circle and a tangent, what kind of angle does the radius and then the right angle, point of tangency? Isn't that what we have here?
Yeah.
Does that make sense? So does this, right? You get a right triangle again. This is also a semicircle, right? This is a triangle, right? This triangle must be, that angle must be 90. So guess what? Radius and then this line here, they make, they're perpendicular, therefore KP also has to be a tangent.
Yeah.
Does this make sense, class?
Yes.
Okay, can you do then a construction like this? Do you see where we get JP and KP here? Yes? The key is you connect O and P, figure out the center so that you get the radius of this big circle. Right? The intersection of these two radius, right? I mean, intersection of these two circles, right? Those 2 points are the point of tangency. Does this make sense? So I like this picture better because then you could actually see the semicircle and so forth. Yes? Go ahead, everybody try yourself. Oh wait, okay, go ahead, everybody try constructing this.